Okay, today we are going to learn how to multiply with exponents. This is part of the first law of exponents. Um, with our notes here, there's a couple things we want to know and remind ourselves when it comes to terms. We need to identify the base, the coefficient, and the exponent of this term, 4x to the seventh. The base is always what the exponent is attached to. So the base here would be x. The coefficient is how many times that x value is being multiplied, which is the 4. It's the large number before the exponent, excuse me, before the variable. And the exponent is always the small number that is attached to the base. That would be 7. If we were asked to expand the following, if you think of a rubber band and you pulling a rubber band and you're expanding it, expanding the x to the third and the x to the fourth, this would be like saying x times x, and then for the x to the third, and then multiplying that times x to the fourth, which is x times x times x times x. Now, altogether, if we remember, that when you multiply, we add the exponents. So we would have all ones here. So how many ones do we have? 1, 2, 3, 4, 5, 6, 7. So this would be x to the seventh power. So that brings us to our product rule that whenever we have bases that are the same, and that's very important, the bases must be the same, that we always add the exponents because 3 plus 4 gives us 7. So ax to the a power times x to the b power would be x to the a plus b. We add the exponents. Okay, so now if coefficients are present, separate the coefficients from the base because coefficients follow multiplication. We would not be adding them. It's only the bases raised to the exponents. The bases would stay the same and the exponents would be added. The coefficients would be multiplied. Now in this case for number 1 for our model problem, we have 11 to the fourth power times 11 to the third power. Now the exponents are attached to the base 11. So as long as the bases are the same, which they are, we keep the base and we add the exponents. So 4 plus 3 gives us 7, so 11 to the seventh power. For number 2, we have now here, we have bases of n, we have exponents that are attached to them, and we also have coefficients. So we need to separate this by 2 times 3, coefficients follow the multiplication, and then n to the 5 plus -2, because we add the exponents. So 2 times 3 is 6, and then n to the 5 plus -2, so it's the same thing as saying 5 minus 2, so that's n to the third power. Now at this time you can pause the video, try your check for understanding, and then come back and check your answers. Okay, so here, number 1, 5 squared times 5 to the eighth power. Bases are the same. They happen to be numbers. That's okay. They don't always have to be variables. So it's 5 to the 8 plus, 2 plus 8, or 8 plus 2. It really doesn't make a difference because multiplication is commutative. And it'd be 5 to the 10th power. For number 2, we have coefficients. So we have a 4, a 7, and remember there is a 1 here. So 4 times 7 times 1. And then we have y's. All the bases are the same, so we can add the exponents. 5 plus 3 plus 6. And we have 4 times 7 is 28, times 1 is 28. Y to the 5 plus 3 is 8. 8 plus 6 is 14. And this is how we multiply with exponents. You just have to remember when you're multiplying, you add the exponents, but the coefficients follow the multiplication rule. Have a great day, guys.